You tap a screen to order a highly specific, obscure item, and a cardboard box arrives on your doorstep in less than 12 hours. That speed is the result of supply chain analytics physically routing cargo to a local distribution center before you even initiated the checkout process. To understand how a system anticipates a purchase, look at this image of an operator at a vintage IBM terminal. Traditional relational database management systems operated exactly like this. They were strictly passive systems of record, built to log transactions only after a sale was completed. Predicting a future purchase requires capturing the chaotic behavior that happens before a credit card is ever swiped. That means tracking every mouse hover, abandoned cart, and rapid-fire search query in real time. Standard relational databases require a predefined structural blueprint of rigid tables and rows. If you attempt to force millions of unstructured, erratic web traffic events into that rigid schema, the system shatters under the volume. To anticipate consumer actions, an e-commerce platform must abandon simple tables and build a multi-layered knowledge discovery in databases, or KDD, pipeline to capture and structure the chaos. The first phase of this KDD pipeline is ingestion. These endless server racks represent the horizontal scale-out architecture of NoSQL databases like Cassandra or MongoDB, which distribute data across commodity hardware to catch billions of erratic clicks without crashing. Instead of splitting data across strict columns, the NoSQL database stores every user interaction as a lightweight JSON document, JavaScript object notation. You can see how the document dynamically adds new key value pairs as a user scrolls down a page or hovers over an image.
Because JSON is schemaless, the database instantly absorbs completely new data attributes on the fly, avoiding the strict structural rules of older systems. But these raw, scattered JSON logs cannot predict global trends on their own. They must be cleaned and integrated. This is the integration phase. The chaotic JSON documents flow through an ETL process, extract, transform, and load, where they are standardized and packed into a massive corporate data warehouse, structured here as a multi-layered geometric cube. Inside the warehouse, the data is organized into a star schema. A central fact table holds the hard numerical metrics, connecting radially to dimension tables that store descriptive details like the user's region or the product category. This specific layout allows online analytical processing engines, OLAP, to instantly slice and dice millions of historical records from multiple angles. A data warehouse perfectly structures the past, but it remains a dormant library of facts. It requires a mathematical engine to extract future predictions from those records. The third phase of KDD is prediction. The system deploys descriptive data mining algorithms to scan the warehouse and uncover hidden correlations. This animation maps out market basket analysis, a form of association rule mining. The algorithm calculates the frequency of items co-occurring. By finding that flashlight buyers almost always purchase D batteries, it establishes a mathematical probability binding the two items together. Next, predictive algorithms, like regression models, apply those baseline rules to a specific user's behavioral profile. By analyzing a user's recent clicks against the established rule, the system calculates their exact probability of making a purchase tomorrow, assigning them a purchase probability score. Possessing a high probability score is completely useless if it does not result in the physical movement of goods. The final phase of KDD is action. The system uses active databases to execute decisions automatically. Active databases rely on an event-condition-action architecture. The database is programmed to constantly monitor prediction scores. When a user's probability score hits a specific threshold, the condition, the database automatically generates a physical supply chain routing order, the action. By bypassing human intervention entirely, this architecture creates an autonomous loop that physically relocates inventory to a local warehouse before the user has even decided to click buy. The lifecycle of a single click begins as a messy JSON log captured inside a highly scalable NoSQL database. It moves through an ETL pipeline, where it is cleansed and integrated into the highly structured star schema of a data warehouse. It is then processed by a predictive data mining algorithm to generate a mathematical probability score. Finally, that score triggers an active database's ECA protocol, initiating a physical supply chain movement. Databases have evolved from digital filing cabinets into advanced decision support systems.
Through the knowledge discovery pipeline, the isolated digital data you generate today actively routes the physical cargo ships and delivery trucks of tomorrow. In modern e-commerce, the only way to deliver the future on time is to anticipate it.